In this session, we will present a new chapter of Conics-Ellipse Grade 12 GS section. At the end of this chapter, we will be able to recognize an ellipse, write an equation of an ellipse, study the properties of an ellipse. Let's start with an activity. The next graph E is that of equation x squared over 10 plus y squared over 6 equal 1. Verify that the origin and the coordinates axes are elements of symmetry of E. Replace x by minus x and y by y. We get the same equation. Then y prime y, axis of symmetry. And replace again x by x and y by minus y. We get the same equation. Then x prime x, axis of symmetry. Therefore, the origin, the x-axis, and the y-axis are the elements of symmetry of E. Consider the point F to 0 and the line delta with equation x equal 5. For any point M on E, prove that distance from M to F over distance from M to delta equal 2 over radical 10. Let mxy belong to E. Use distance formula between 2 points. We get mf squared equal x minus 2 squared plus y squared. Since mxy belong to E, then their coordinates satisfy the equation of E. We substitute y squared by minus x squared over 10 plus 1. We get 2 into x minus 5 squared over 5. If L is the orthogonal projection of M on delta, then the coordinates of L are 5 and y. ML squared equal x minus 5 all squared. Hence, mf squared equal 2 over 5 ml squared. Therefore, distance from M to F over distance from M to delta equal 2 over radical 10. Note that 2 over radical 10 is less than 1. And we notice that if we move M on E, distance from M to F over distance from M to delta remains equal 2 over radical 10. Consider the point f prime minus 2, 0, and the symmetric of M with respect to y prime y, and the line delta prime with equation x equal minus 5. Prove that distance from M to f prime over distance from M to delta prime is constant. Since n is the symmetric of M with respect to y prime y, then n is on E. Therefore, n satisfies the relation nf over nl equal 2 over radical 10. And by symmetry we have nf equal mf prime and nl equal ml prime. Therefore, distance from M to f prime over distance from M to delta prime equal distance from M to f over distance from M to delta equal 2 over radical 10. Prove that mf plus mf prime equal AA prime. mf equal 2 over radical 10 absolute value of x minus 5 calculated before. Same for mf prime equal 2 over radical 10 absolute value x plus 5. mxy varies on E. Then x between minus radical 10 and radical 10. Then absolute value of x minus 5 equal 5 minus x, and absolute value of x plus 5 equal x plus 5. Therefore, mf plus mf prime equal 2 over radical 10 into 5 minus x plus 2 over radical 10 into x plus 5 equal 2 radical 10 equal AA prime. Let's move to another activity. E is the curve with equation x squared over 9 plus y squared over 25 equal 1. Determine the meeting points of E with the coordinate axes. Let y equal to 0. We get b 3 0 and b prime minus 3 0. Then let x equal to 0. We get a 0 5 and a prime 0 minus 5. Determine the elements of symmetry of E. Elements of symmetry of E: the origin, x-axis, and y-axis. Same proof as previous activity. Verify that L 9 over 5, 4 is a point on E. To check if a point is on a graph, we replace the coordinates of this point in the equation of a graph. Then, the coordinates of L satisfy the equation of E. Use L to find 3 other points on E. Since the elements of symmetry of E are the origin I, the x-axis, and the y-axis, then L1 minus 9 over 5 minus 4 is the symmetry of L with respect to O. L2 minus 9 over 5, 4 is the symmetry of L with respect to y prime y. L3 9 over 5 minus 4 is the symmetry of L with respect to x prime x. L1, L2, L3 are all on E. Plot E, then estimate the area of E. We draw E by joining A, L, B, L3, A prime, L1, B prime, L2. Let's move to the text of chapter. Definition of ellipse. An ellipse E with focus F, directrix delta, and eccentricity E is a set of points M of the plane so that distance from M to F over distance from M to delta equal E, with E between 0 and 1. The focal axis of E is the line through the focus and perpendicular to the directrix. The meeting points of E with the focal axis are the principal vertices A and A prime. The center I of E is the midpoint of segment AA prime. The non-focal axis of E is the line through the center and perpendicular to the focal axis. The meeting points of E with the non-focal axis are the secondary vertices. An equation of ellipse with center I alpha beta and horizontal focal axis in standard form is x minus alpha squared over a squared plus y minus beta squared over b squared equal to 1. A is the distance from I to one of the principal vertices A or A prime, and B is the distance from I to one of the secondary vertices B or B prime. Note that A is always greater than B. In this equation, the fraction with denominator A squared has x minus alpha squared as numerator. Then, the focal axis is parallel to the x-axis, and y equal beta is an equation of this focal axis. The equation of the non-focal axis is x equal alpha. A prime, B and B prime are the vertices of E. F and F prime are the foci of E. Delta and delta prime are the directrices of E. IA equal IA prime equal small a. IB equal IB prime equal small b. IF equal IF prime equal small c, with a squared equal b squared plus c squared, and E equal c over a less than 1. Distance from I to delta equal distance from I to delta prime equal a squared over c. For any point M on E, distance from M to F over distance from M to delta equal distance from M to F prime over distance from M to delta prime equal E. Parameter of ellipse equal E times distance from focus to directrix. For any point M on E, MF plus MF prime equal AA prime equal 2 small a. We notice that if we move M on C, MF plus MF prime remains equal to AA prime equal to 2 small a. Let's move to an ellipse with vertical focal axis. An equation of ellipse with center I alpha beta and vertical focal axis in standard form is x minus alpha squared over b squared plus y minus beta squared over a squared equal 1. As we mentioned earlier, a always greater than b. In this equation, the fraction with denominator a squared has y minus beta squared as numerator. We conclude that the focal axis of this ellipse is parallel to y prime y, and x equal alpha is an equation of this focal axis. Y equal beta is an equation of the non-focal axis. A prime, B and B prime are the vertices of E. F and F prime are the foci of E. Delta and delta prime are the directrices of E. IA equal IA prime equal small a, and IB equal IB prime equal small b. IF equal IF prime equal small c, with a squared equal b squared plus c squared. Distance from I to delta equal distance from I to delta prime equal a squared over c. E the eccentricity equal c over a less than 1. For any point M on E, distance from M to F over distance from M to delta equal distance from M to F prime over distance from M to delta prime equal E equal C over A. MF plus MF prime equal AA prime equal 2 small a. Parameter of ellipse equal E times distance from focus to directrix. Area of ellipse equal pi times A times B. Let's move to an example. In the next figure, F and F prime are two fixed points, so that FF prime equals 6 and O is the midpoint of segment FF prime. M is a variable point so that the perimeter of triangle MFF prime remains equal to 16. Prove that M moves on an ellipse E. Perimeter of triangle MFF prime equal to MF plus MF prime plus FF prime equal to 16. Since FF prime equal to X, then MF plus MF prime equal 10. Therefore, M moves on the ellipse with foci F and F prime so that 2A equal 10. determine the focal axis of E, and so the vertices of E on this axis. The focal axis is the line FF prime. An ellipse has 4 vertices, 2 of them on the focal axis and the others on the non-focal axis. The vertices on FF prime are A and A prime, so that OA equal OA prime equal small a equal 5. O is the center of E. Calculate E, the eccentricity. E equal C over A equal OF over OA equal 3 over 5, and it's less than 1. The plane is referred to the system OIJ with I equal 1 over 3 vector OF. Write an equation of E. To determine an equation of E, we need A squared, B squared, the coordinates of the center, and the focal axis. We already know the coordinates of the center O, 0, 0. A squared is equal to 25, and x prime x is the focal axis. We still need to calculate B squared. A squared equal B squared plus C squared. So, B squared equals 16. Let's write this equation. X minus 0 all squared over 25 plus y minus 0 all squared over 16 equal to 1. We notice that the denominator of this fraction is a squared because x prime x is the focal axis. Determine the vertices of E on the non-focal axis, then draw E. B squared equals 16. Then B equal 4 and OB equal OB prime equal 4. Therefore, B 0, 4 and B prime 0 minus 4. Write equations of directrices of E. The directrices of E are perpendicular to the focal axis x prime x. And we know that distance from O to delta equal distance from O to delta prime equal a squared over c. Therefore, an equation of delta is x equal a squared over c equal 25 over 3, and that of delta prime is x equal minus a squared over c equal minus 25 over 3. Thank you.